Welcome you all in the lecture number 8 of Engineering Mathematics 1 MTL 1025. In this lecture, we will going to discuss some problem of Jacobian and the properties of Jacobian. Find the Jacobian of y1, y2, y3 with respect to x1, x2, x3, where y1 is given by x2, x3 by x1 and y2 is given by x3, x1 by x2 and y3 is given by x1, x2 by x3, right? Then Jacobian J is given by dou of y1, y2, y3 of dou x1, x2, x3, right? And this is equal to dou y1 dou x1, dou y2 dou x2, dou y1 dou x3, right? First row, first dependent variable and their partial derivatives with respect to x1, x2, x3. Similarly, second row of this y2 with respect to x1, x2, x3 and third row of y3 with respect to x1, x2, x3. Then what is dou y1 by dou x1? What is y1? y1 is given by this relation, right? Then dou y1 by dou x1 is equal to minus x2 x3 divided by x1 square, and this is y1, and dou y1 dou x2 is given by dou y1 dou x2 is given by x3 by x1, and dou y1 by dou x3 is given by x2 x1. Means differentiate this, dou y1 by dou x1 is equal to minus x2 x3 divided by x1 square, and dou y1 by dou x2 is equal to x3 by x1, and dou y1 by dou x3 is equal to x2 by x1, right? This one. Similarly, dou y2 by dou x1 is x3 by x2, dou y2 by dou x2 is minus x3 x1 by x2 square, and dou y2 by dou x3 is equal to x1 x2. Similarly, third row dou y3 dou x1 is this, and dou y3 dou x2 is this, dou y3 dou x3 is this, right? Now, taking 1 upon x square, x2 square, x3 square is common, then this thing will be x2 x3. Now multiply here. Now from this row, taking 1 upon x1 square, from this one 1 upon x2 square, and from this one 1 upon x3 square, right? Then multiply here by x1 x3, and in this term by x1, that is x1 x2, right? And taking x2 x3 from first column, x1 x3 from second column, and x1 x2 from third column, right? This gives x1 square, right? These three gives x1 square plus x1 square into x2 square into x3 square divided by x1 square, x2 square, x3 square, and this is minus 1 1 1 1 minus 1 1 1 1 minus 1, and the value of this determinant is 4. This is cancelled out, and the value of this determinant is 4. Therefore, Jacobian of y1 y2 y3 with respect to x1 x2 x3, where y1 y2 y3 is related by these equations, right? Now see the properties of the. Now see the first property. What is first property? If u and v are the function of x and y, then dou of ub dou of xy equal to j, and dou of xy and dou of ub equal to j dash. Then first property says that j dash is equal to 1. It means these two numbers are inverse of each other, right? See the proof. Let u is equal to fxy and v is equal to gxy, right? Then u is function of xy, and we also know that x is function of uv, right? What is u? U is equal to fxy, right? Now dou u by dou u is equal to 1. What is dou u by dou u? Dou u by dou x into dou x by dou u plus dou u by dou y and dou y by dou u. Since u is function of xy, this is function of uv, and this is function of uv. And see the diagram, right? With this diagram you can obtain this. Similarly, differentiating this u with respect to v, dou u by dou v. What is dou u by dou v? Derivative of this u is 0 since it is independent from v, and this is equal to dou u by dou x by dou v. See in this diagram how many path from u to v? That is one path, u to x, x to v, u to y, y to v, plus dou u by dou y by dou v. This is 0, right? Similarly, you can differentiate this second equation also. You got second row. It means this is 1, this is 0, this term is 0, and this term is 1, right? Then this is the identity matrix 1 0 0 1, and this is 1, right? See, these are the derivatives, and the product is 1. It means dou of ub and dou of xy is equal to 1 upon dou of xy into dou of u, right? See one example. If x is equal to uv and y is equal to u plus v divided by u minus v, what is this? Dou of ub and dou of xy, right? There are two methods of finding this. In first method, either you find u and v as a function of xy, right? Either you evaluate this using these two equations, this equation and this equation, or using property 1, right? Then dou of xy with respect to dou of ub is equal to dou of xy dou of ub is equal to dou x by dou u, dou x by dou v, dou y by dou u, dou y by dou v, right? What is dou x by dou u? V. From this, dou x by dou v, u, dou y by dou u, from this, dou y by dou u, differentiating this partially with respect to u, minus 2v, u minus v square, and differentiating this partially with respect to v, 2u, u minus v square, right? From this row, you take common 2 divided by u minus v square, right? This one, and you can take 2 common also, and this is, right, from this one, from this column v and from this column u, then this is 2ub divided by u minus v square, and this is 1. And solving this, what is the determinant? This determinant is 2, and 2 multiplied by 2ub, that is 4ub divided by u minus v. But we have to find out this one, dou ub by dou xy. What is dou ub by dou xy? That is 1 upon dou xy by dou uv. It means dou xy is equal to 1 upon dou of ub, dou of ub dou xy is equal to 1 upon dou xy by dou uv, right? and this is equal to u minus b square divided by 4ub. Now see another example. If u is equal to x, y, z and v is equal to this and w equal to this, then what is this? What is the Jacobian of this? Right? Solving this by using property number 1. First you find dou ubw with respect to dou xyz, and this is equal to dou u by dou x, dou u by dou y, dou u by dou z, dou v by dou x, dou v by dou y, dou v by dou z, and this is dou w by dou x, dou w by dou y, dou w by dou z, right? And this is equal to dou u by dou x, yz, dou u by dou y, zx, dou u by dou z, xy, and dou v by dou x, 2x, dou v by dou y, 2y, dou v by dou z, 2z, and dou w by dou x is 1, dou w by dou y 1. Now solving this determinant, we got this, and then this is j dash. What is j into j dash? Is 1. Then what is j? 1 upon j dash. 1 upon this is j dash. Right? Next, what is the second property? Second property is the chain rule. Means if u and v, these are the function of r and s. This is function of rs, and rs is the function of xy. Right? Then what is the Jacobian of uv with respect to xy? Right? This is given by dou ub, dou rs, and dou xy. Right? This rule is known as chain rule. Right? Using this chain rule, we can solve this problem. What is the problem? U equal to x square minus y square, and v equal to 2xy, x equal to r cos theta, and y equal to r sin theta. Then we have to evaluate that dou uv of dou xy. Right? What is dou uv of dou xy? Using these two equations, we can find dou ub by dou xy. Dou u by dou x, 2x. Dou u by dou y, minus 2y. Dou v by dou x, 2y. Dou v by dou y, 2x. Right? Solving this, we got 4 into x square plus y square, that is 4r square. Similarly, if x equal to r cos theta and y equal to r sin theta, then we already solved in previous lecture dou xy by dou r theta is equal to r. Now multiplying these two terms, right? Multiplying these two terms, we got 4r cube. Right? This is 4r cube. Now see another example. U is equal to x plus y plus z. U square v is equal to y plus z, and u cube w is equal to z. Right? Let us apply some transformation. Let r is equal to x plus y plus z, s is equal to y plus z, and t is equal to z. What is x plus y plus z? U. What is y plus z? U square v. What is z? U cube w. It means r is equal to u, s equal to this, and t equal to this. Right? Okay. What we have to evaluate? We have to evaluate dou of uvw, dou of xyz. Right? Then we have to apply chain rule. Dou of UBW of dou of RST into dou of RST divided by dou of XYZ. What is dou of UBW with respect to RST? Right? Evaluation of this, you have to find out that what is U in terms of RST, what is V in terms of RST, and what is W in terms of RST. Right? Instead of doing this, we know that what is R? R is U. What is S? U square V. And what is T? U cube W. That is RST is this one. Right? Then dou UBW, dou RST. This can be written as in this form. Evaluate this. It means if we evaluate, right? If we evaluate dou of RST divided by dou of UBW, and what is R? U. What is S? U square V. What is T? U cube W. Right? Then what is this? This is dou R by dou U, that is 1. Dou R by dou V, 0. Dou R by dou W, 0. Now come to S. What is dou S by dou U? 2UV. Right? Dou S by dou V, U square. And dou S by dou W, no term of W here, therefore T0. Now dou T by dou U, 3U square W. Dou T by dou V, no term of B, therefore it is 0. Dou T by dou W, U cube. Now solve this determinant. What is this determinant? This determinant is U to the power 5. Now what is RST with respect to XYZ? Dou of RST with respect to dou of XYZ is equal to determinant dou R by dou X. What is dou R by dou X from this equation? 1. Dou R by dou Y, 1. Dou R by dou Z, 1. Now dou S by dou X, here no term of X, therefore this partial derivative is 0. Dou S by dou Y, 1. Dou S by dou Z, 1. Now dou T by dou X, no term of X, 0. In this T and relation of T and Z. Dou T by dou Y, 0. Dou T by dou Z, 1. Right? What is this determinant? 1. Then this thing is 1 and this one is U5. Therefore, this is 1 upon U to the power 5 into 1. Right? So this is equal to U to the power minus 5. Now, see the third property. If function UBW, right? This is one of the most important property for the functional relation, right? If you have to find out that whether UBW are connected by some functional relation or not, then if UBW are three independent variable, function of three independent variable XYZ are not independent, means UBW are not independent and they are the function of XYZ. UBW are not independent and they are the function of independent variable XYZ. Then dou UBW dou XYZ is equal to 0. It means then Jacobian of this UBW with respect to XYZ is 0. Right? Now you prove that. Let UBW are not independent. Let us assume that. Sorry, it is given that. Then it is not independent. It means they are dependent. They are dependent. They have some functional relation. Then f of UBW equal to 0. Right? F of UBW is equal to 0. F of UBW is equal to 0. What is F? F is a function of U, V, W. What is U? U is function of X, Y, Z. Similarly, X, Y, Z. X, Y, Z. Right? Then dou f by dou u, right? Differentiating this equation with respect to x. Then dou f by dou x, sorry, dou u, and dou u by dou x. One path from f to x, and dou f by dou b by dou x. Dou f by dou w and dou w by dou x is equal to 0. There are three paths from f to x. One is f to u, u to x, f to v, v to x, f to w, w to x, right? Similarly, other path, dou f by dou v and dou f by dou u by dou y plus dou f by dou v by dou y, dou f by dou w by dou y is equal to 0. And third one, dou f by dou u by dou z plus dou f by dou v by dou z, dou f by dou w by dou z is equal to 0, right? Then we obtain these three equations. From this equation, eliminating dou f by dou u, dou f by dou v, dou f by dou w. Then we got this determinant, dou f by dou u, eliminate this. This one is the first column. Dou f by dou v, and this one is the second column. Dou f by dou w, then this one is the third column, right? First column, second column, and third column, right? We obtain this determinant. Then solving this determinant, what we have to do? Interchanging in this one, interchanging rows and columns, right? You got this one. And what is this? This is nothing else but dou ubw with respect to dou xyz equal to 0, right? Next, see the remark. If it is given that, conversely, if we discuss about the converse part of this, dou of ubw and dou of xyz equal to 0, then ubw are not independent of one another, then they are connected by the relation this. It means its converse part is also true. The converse part of property number 3 is true, right? Now see the example related to the property number 3. What is u? U is equal to xy plus yz plus zx. What is v? X square plus y square plus z square. What is w? X plus y plus z. That u, v, w is the function of x, y, z. We have to determine that whether there is any relation between u, v, w, right? For this, we have to evaluate the Jacobian. That dou ubw, dou ubw with respect to ex, y, z, and this is equal to y plus z, z plus x, ex plus y, and 2x, 2y, 2z, 1, 1, 1, right? Then adding row 1 and row 2 and taking common this 2x plus y plus z, this becomes 1, 1, 1, and this is x, y, z, right? And this is 1, 1, 1, right? Since these three first and third row are equal, therefore this determinant is 0, right? This j is 0, then property number 3 says that there is a relation between u, v, w. You have to find out that relation. What is that relation? If v square w, that is x plus y plus z whole square, what is this? X square, y square, z square plus 2 times xy, yz, zx. What is x square plus y square plus z square? This is equal to v plus 2 times, what is this? This is u. It means w square is equal to v plus 2u. This is the functional relation, right? This Jacobian j is equal to 0 only tells you that there is a functional relation, but what is the functional relation? You have to find out that. See another example. If u is equal to x plus y minus z and v is equal to x minus y plus z and w is equal to x square plus y square plus z square minus 2yz, then what is the functional dependency? UVW. If there is any functional dependency, then whether they are related with each other or not, right? They are related with each other if we find their Jacobian is 0, that is dou of UVW with respect to dou of XYZ, that is 0. If this is 0, then f of UVW is equal to 0. There is some function such that which relate this UVW. What is that function? We have to check it. But before that, you have to find out that this Jacobian is 0 or not. Let us see. Dou of UVW, dou of XYZ, that is dou u by dou x 1, dou u by dou y, dou u by dou z, right? And dou v by dou x, dou v by dou y, dou v by dou z, right? Dou w by dou x 2x, dou w by dou y 2y minus 2z, and dou w by dou z 2z minus 2y. Solve this determinant. This determinant is equal to 0. And this tells us that u, v and w have functional dependency. Functional dependency. Right? But what is the functional? This I have to see. See, if u square plus v square, what is u square plus v square? X plus y minus z square plus x minus y plus z square, and this is equal to x square plus y square plus z square plus 2xy minus 2yz minus 2zx and plus x square plus y square plus z square minus 2xy minus 2yz minus plus 2zx. Now add them. This term is cancelled out, and this is equal to 2 times x square plus y square plus z square minus 2yz. And what is this? This is w. It means u square plus v square is equal to 2w. Right? Now see some other property. What is the Jacobian of implicit function? Right? Jacobian of implicit function. Suppose if x, y, u and v are connected by this function and this function, it means f1 x, y, u, v is equal to 0, f2 x, y, u, v is equal to 0, right? And u, v are implicit function of x, y. This f1 x, y, u, v is equal to 0. It means del f1 by del x plus del f1 del u by del x del f1 by del v del v by del x equal to 0. Why? This f1 is function of ub and ub is function of xy. It is given, right? And similarly, del f1 upon del y plus del f2 by del x and del f2 by del y, right? Then using these terms, we can find out that dou f1, we will use these relations, that is 3, 4, 5 and 6 as follows. See, if we consider dou f1 f2 with respect to dou ub, what is this? Dou f1, dou u, dou f1, dou b, dou f2, dou u, dou f2, dou b, right? Similarly, dou of ub, dou of xy, dou u dou x, dou u dou y, dou v dou x, dou v dou y, right? Multiplying these two terms, dou f1 f2, dou of ub into dou of ub, dou of xy, right? Multiplying this term, we got these terms. See this one. Entries of this determinant is this one, right? Then this can be written as minus dou f1 by dou x minus dou f1 by dou y minus dou f2 by dou x minus dou f2 by dou y, right? And solving this determinant, we got minus 1 square dou f1 dou f1 f2 dou xy, right? Then dou ub dou xy is given by dou f1 dou f1 f2 with respect to xy and dou f1 dou f2 respect to ub, right? This is the relation. This is the Jacobian of implicit function. Jacobian of implicit function, right? Okay, let us see one example. If x square plus y square plus u square minus v square equal to 0, this is the one function, and ub plus xy is equal to 0, this is another function. Now see, if f1 is equal to x square plus y square plus u square minus v square equal to 0 and f2 is equal to ub plus xy equal to 0, right? Then what is dou ub with respect to xy, dou of xy? This is dou f1 dou xy. Now dou f1 f2 dou of ub, right? Evaluate this term and dividing each other, right? Dou f1 by dou f, see, dou f1 f2 with respect to xy, what is this? Dou f1 by dou x, dou f1 by dou x is equal to 2x. Dou f1 by dou y, 2y. Dou f2 by dou x, this is y. Dou f2 by dou y, this is x, right? And this is equal to 2x square minus y square. This is the numerator. Similarly, for denominator, right? This is the denominator. Then this dou ub dou xy is equal to this by the properties of Jacobian for implicit function. Okay. Now we will stop here. In next lecture, we will discuss what is the asymptotes and the problem related with the asymptotes. Okay. Thank you.